Hello, traveler. My name is Dr. Kobakos. Welcome to my channel. For more than 40 years, I have studied nature and the knowledge surrounding it. Over time, I noticed something troubling. Information about medicinal plants is rarely discussed, rarely promoted, and often quietly ignored. We live in a world where health is treated as a product, and large industrial systems influence what is researched, what is promoted, and what remains unseen. In this video, I will show how modern views on medicine and health have been shaped, and in some cases distorted, by economic interests. Interests that do not benefit from people staying healthy or relying on the free resources that nature provides. Piece by piece, plant by plant, I gathered what was left behind. I do not promise miracles. I present observation, history, and evidence, because people must know the truth. An amaranth. You've seen this plant 1,000 times, on roadsides, in vacant lots, growing where nothing else will. Tall stalks with broad green leaves and distinctive reddish-purple seed heads that look like foxtails. Most people call it pigweed, a weed to be pulled out and discarded. But I know what it really is. This is amaranth, and for 8,000 years, it fed empires. Let me light another candle here in my archive. Before you on this table lies a glass jar filled with small reddish grains, each one smaller than a sesame seed. These are amaranth seeds, amaranthus. The ancient Greeks called it amaranthos, the unfading one. One plant produces 40,000 to 60,000 seeds per season. The leaves are edible. The seeds contain 13 to 14% protein, higher than wheat or rice. Most importantly, amaranth contains lysine, an essential amino acid that wheat and corn lack almost entirely. This isn't speculation. This is documented nutrition science. But here's what they don't teach you. This plant was once as important to the Americas as wheat was to Europe, and then it was deliberately erased. The year is 1519. Hernán Cortés arrives in the Aztec Empire. In the Valley of Mexico, amaranth, called huatli in Nahuatl, was one of 3 primary crops, alongside maize and beans. Archaeological evidence shows continuous cultivation for at least 6,000 years. Annual tribute records show that subject provinces sent 15,000 to 20,000 tons of amaranth to Tenochtitlan every year. 20,000 tons. Enough to provide 200 calories daily to 1.5 million people for an entire year. The population of Tenochtitlan was between 200,000 and 400,000. The amaranth tribute alone could have fed the entire city several times over. In the Andes, the Incas called it kiwicha and grew it at high altitudes, 3,000 to 3,800 meters, where other crops struggled. At those elevations, with short growing seasons and poor soil, amaranth thrived. The Aztecs integrated amaranth into their religious ceremonies. During festivals, priests would grind amaranth seeds into flour, mix it with honey, and sculpt figures of their gods, tsoali figures. Some reached the height of a man, carried through streets during processions. At the festival's culmination, these figures would be broken apart and distributed. Everyone present, nobility and commoners alike, would eat. This is documented fact, recorded by Spanish priests like Bernardino de Sahagún in the Florentine Codex. These ceremonies weren't primitive superstition. The Aztecs were sophisticated urban civilizations with complex mathematics, accurate astronomy, and impressive architecture. They integrated Amaranth into religious practice because they understood that what feeds the body is sacred. One Aztec farmer could produce enough amaranth to feed his extended family with surplus remaining. The plant required no complex irrigation, no expensive tools, no external inputs. A farmer saved seeds from each harvest to plant the next, indefinitely. He was, fundamentally, free. And that was the problem. Empires aren't built on freedom. They're built on control and dependency. When Cortés arrived with fewer than 600 soldiers, he brought more than weapons. He brought a different conception of how society should be organized, how food should be controlled. The Spanish saw the amaranth fields and ceremonies. They watched thousands consuming tzoali figures in rituals uncomfortably similar to Catholic communion. In 1577, Viceroy Martín Enríquez formally prohibited amaranth cultivation. The official reason was religious. The ceremonies were declared blasphemous. But read the colonial administrator's private correspondence. Yes, they mention religion, but they also mention the danger of allowing the native population too much food independence. A population that can feed itself doesn't need you. A population that doesn't need you won't obey you. The penalties were severe. Fields found growing amaranth were burned. Stored seeds were confiscated and destroyed. Within 50 years, amaranth cultivation had dropped by 90%. Within a century, it existed only in remote mountain villages where Spanish authority couldn't reach. But the Spanish couldn't kill the plant itself. Amaranth seeds can remain viable in soil for 40 years or more, lying dormant. When fields burned, not every seed burned. Seeds scattered on wind. Birds carried them. They fell into cracks in walls, rolled into forgotten corners, were carried on farmers' clothes between regions. The plant adapted. It moved from cultivated fields into wild spaces, into margins where oversight was impossible. And this is how the greatest trick was accomplished. Not by destroying amaranth physically, which proved impossible, but by changing how people perceived it. What grows without permission becomes a weed. What can't be controlled becomes worthless. The transformation was complete, from sacred grain to roadside nuisance in a few generations. Now we move forward. The colonial period ends. New nations form. But amaranth remains marginalized, grown only by those who never forgot or were too isolated to lose the knowledge. Then comes 1960 and the Green Revolution. Norman Borlaug develops new varieties of semi-dwarf wheat, producing dramatically higher yields. In 1970, he receives the Nobel Peace Prize for feeding the world. The narrative is straightforward. Science defeated hunger through innovation. But here's what the story omits. Those high yields required specific inputs: chemical fertilizers, pesticides, irrigation, mechanized equipment. The seeds were hybrids that didn't breed true. Farmers couldn't save seed but had to purchase new seed each season. Development agencies spread across Mexico, Peru, Guatemala. They held workshops, provided training, offered loans. Everywhere they delivered the same message: your traditional crops are holding you back. Amaranth, quinoa, they're primitive, they represent poverty. Plant improved varieties, use chemical fertilizers, join the modern world. The logic was persuasive, especially to young people eager to escape rural poverty. Agricultural universities restructured curricula around the new paradigm. Research funding flowed to high-yield varieties, not traditional crops. By 1975, amaranth had virtually disappeared from mainstream agriculture. Let me show you data from researchers in the 1970s who still studied these forgotten crops. Nutritional composition per 100 grams. Amaranth has 13 to 14% protein versus wheat's 10 to 14% and rice's 7 to 8%. But the real difference is lysine content. Amaranth contains approximately 6% lysine by weight of total protein. Wheat contains about 2%. Corn about 2.5%, rice about 3.5%. Lysine deficiency causes stunted growth in children, poor wound healing, fatigue, inability to concentrate. Amaranth provides a complete amino acid profile from a single plant source. Mineral content. Calcium 159 milligrams per 100 grams. Wheat has 29 milligrams. Iron 7.6 milligrams. Wheat has 3.5 milligrams. Water requirements. Amaranth needs 300 to 500 millimeters per growing season. Wheat needs 450 to 650 millimeters. Rice needs 900 to 1500 millimeters. Amaranth thrives in soil pH from 4.5 to 8.5. It tolerates high salinity. It grows in soil too poor for wheat or corn. It matures in 90 to 120 days and can be planted multiple times yearly in warm climates. These are results from peer-reviewed agronomic research, not myths or exaggerations. Now tell me, in a world facing water scarcity, soil degradation, climate instability, and persistent malnutrition, why abandon such a plant? The only logical answer is that it doesn't fit the economic model. You can't patent it. You can't sell proprietary inputs for it. There's no profit in a plant that reproduces freely and makes farmers independent. I'm not describing conspiracy. I'm describing systemic logic. An economic system organized around profit maximization will push out anything that doesn't generate profit, regardless of utility. But something unexpected happened in the late 1970s. A botanist named John Robson, working with the Rodale Research Institute, was traveling through Mexico studying traditional farming. In remote Puebla villages, he noticed elderly farmers still growing amaranth in small plots. He asked why. The answers were pragmatic. It feeds the family when corn yields are low. It grows without purchased inputs. My grandmother taught me, and it works. Robson collected seed samples and conducted nutritional analysis. He published papers that most colleagues ignored. But NASA didn't ignore them. In 1979, NASA's Ames Research Center evaluated crop species for controlled ecological life support systems. crops that could sustain humans on long-duration space missions. They evaluated hundreds of species against strict criteria: nutritional completeness, water efficiency, oxygen production, rapid growth, minimal waste. Amaranth ranked in the top tier. If you're planning to sustain humans on Mars for months or years, you need plants providing maximum nutrition for minimum inputs. Amaranth qualified. This wasn't speculation. This was serious research by NASA scientists solving real engineering problems. Around the same time, seed banks in Mexico and Peru began preservation programs targeting amaranth. Researchers went into mountain villages to collect diverse varieties. What they found was surprising. In isolated regions, cultivation had never stopped. Women in villages in Oaxaca, in Ayacucho, in highlands of Guatemala still planted amaranth every year. Not many, perhaps a small plot scattered among other crops, but continuously, generation after generation. These weren't romantic traditionalists rejecting modernity. They were pragmatic farmers maintaining a reliable food source. Their reasoning was consistent. Why would I stop growing something that works? The chains of seed saving had never been completely broken. Grandmother to mother to daughter, the knowledge and seeds passed down. Today, amaranth grows across the Americas and beyond. Much wild, volunteer plants on roadsides in vacant lots, but increasingly deliberate cultivation is returning. Small farmers in Mexico are replanting it. Community gardens included. Seed companies are beginning to carry it. The plant never left. It survived 5 centuries of suppression by doing exactly what evolution designed it to do: producing abundant seeds, adapting to conditions, thriving in marginal spaces, waiting for humans to remember. Let me be clear about what I'm telling you. This isn't about a miracle plant that will solve all agricultural problems. It won't. No single crop can. This is about what happens when systems prioritize control over sustainability, profit over nutrition, standardization over diversity. Amaranth was systematically marginalized, first through colonial violence, then through economic pressure. Not because it didn't work, but because it worked too well without generating dependency. Right now, you can find amaranth growing in most temperate and subtropical regions worldwide. Learn to recognize it. Tall plant reaching 1 to 2 meters, broad oval leaves, distinctive drooping seed heads turning deep red or purple in late summer. The entire plant is edible. Young leaves can be harvested and cooked like spinach, more nutritious, with mild, slightly sweet flavor. When seed heads mature and dry, cut them and hang upside down over a sheet. As they dry, seeds will fall, thousands from a single plant. You can toast the seeds in a dry pan. They'll pop like miniature popcorn. You can grind them into flour, cook them as porridge. They have a nutty, earthy flavor. Most importantly, save seeds. Take some from your harvest and store them, cool and dry. Next spring, plant them. Share them with neighbors. This is how food security actually worked for most of human history, through observation, adaptation, seed saving, and plants that want to grow. The system erased this knowledge not through evil conspiracy, but through economic logic. What can't be controlled can't be profited from. What can't be profited from becomes invisible. But the plant never stopped existing. It just waited. I keep these seeds because a woman from Oaxaca gave them to me 20 years ago. Her name was Esperanza, hope. She was in her 50s then, still planting amaranth every spring in the same plot her grandmother used. She told me, "They tried to make us ashamed of this plant. Development workers said it was food for poor people, for backward people. But my grandmother told me, the plant that feeds you is never shameful. Remember that." I asked why she kept growing it when she could buy wheat flour at the store, when modern varieties were available. She looked at me like I'd asked why she kept breathing. "Because it grows," she said simply. "I plant it, it grows. I don't need to buy seeds. I don't need chemicals. I don't need to borrow money. I plant it, it grows, it feeds my family. Why would I stop?" That's the answer. Not romance, not tradition for its own sake. Simple pragmatism. It works. The seed that refused to die is still here, still growing in vacant lots and roadsides, still scattered across landscapes, still producing abundance without asking permission. The question was never whether it survived. The question is whether we'll remember what it is.